Hello and welcome to section 5.6, and this is video number 4. All right, we're going to try and come up with a rational function given the following information. So let's write an equation for the rational function that has vertical asymptotes at x equal 1 and 4, x-intercepts at -2, 0, and 3, 0, and a horizontal asymptote of y equal to 0. All right, well, our rational function r of x is going to be of the fraction form. And from the vertical asymptotes, that tells us the values of the denominator. We know that 1 and 4 are vertical asymptotes, so x minus 1 and x minus 4 must be in the denominator. X-intercepts are at -2, 0, and 3, 0. So that means that x plus 2, or x minus -2, x plus 2, and x minus 3 must be in the numerator to make those x-intercept values. The final thing we need to figure out is the horizontal asymptote. Now remember, we need to remember the rules. If the degree of the top is equal to the degree of the bottom, then the ratio of the leading coefficients is the horizontal asymptote. Well, right now, the way we have it written, the top is degree 2, right? If we multiplied those guys out, it'd be a quadratic. And so is the bottom, right? They're both degree 2. But the horizontal asymptote is not the ratio of the leading coefficients because it's equal to 0. That horizontal asymptote comes up when the degree of the denominator is greater than the degree of the numerator. So to fix that, we need to raise the denominator degree. How do we raise the degree? Well, we add an extra x. So I'm just going to plug in an x right there. And now you may be saying to me, wait a minute, this now has a vertical asymptote at x equal to 0. And yes, it does, but it doesn't say it couldn't have a vertical asymptote at x equal to 0. It just says it has ones at 1 and 4. And this is really the only way we're going to be able to raise the denominator degree without raising the numerator degree. So there's my function. Let's try another one of these guys, this time getting the information from a graph. Let's zoom in just a little bit. All right, let's look at this guy. Where do we see the vertical asymptotes at? Well, it looks to me like -1 is a vertical asymptote, and the other one is 2. So x equal to -1 and x equal to 2 are my vertical asymptotes. Not vertical asymptotes, vertical asymptotes, sorry. And then my brain just stopped there for just a second. Okay, we found our vertical asymptotes. Let's find our horizontal intercepts, or x-intercepts. Well, that looks like it's at -2, 0, and 1, 2, 3, 3, 0. And my horizontal asymptote looks like it's at this value right here, right? If I go along like this, I would say that's at y equal to 2 is my horizontal asymptote. All right, so by reading the graph, I got all this information, and now I can put my function together. I'm going to do it up here in the left-hand corner. R of x equals, all right, well, the vertical asymptotes tell us about the denominator, x minus -1 or x plus 1, x minus 2, x plus 2, x minus 3. And now we need to worry about this a value out front. The degree of the top is the same as the degree of the bottom. So we know that y equal 2 is our horizontal asymptote, so that we don't need to mess with the degrees are matching. But if we want y equal to 2 to be our horizontal asymptote, we need this a value to be equal to 2. And that way the leading coefficients would be 2 from the numerator and a secret 1 from the denominator that we don't always write down. Right? So there's my function for this guy. Now to recap, let's remember the vertical asymptotes tell you about the factors in the denominator. The horizontal intercepts tell you about the factors in the numerator, and the horizontal asymptote tells you about what you need to add number-wise or variable-wise to follow the horizontal asymptote rules.